Assalamu alaikum, my students. Adil sir here, welcoming you again to our unit differentiation. We have already discussed this differentiation on graph, as well as we have given it its definition also. Now we have a topic from this differentiation, and that is power rule of differentiation. And by the help of this power rule, we are getting able to find out the derivative of infinite number of functions. The first one, the first result that is from this power rule, that is this: if we have a function and that the function is of the form x power something, or having exponent n, then the derivative of that very function with respect to this x is equal to xn minus 1. What that means, beta, if we have a function f of x equals to x raised power 3 or x raised power 4, if we have to find the derivative of this function, the derivative of this function is such that this power comes as a factor of, so it will be here 3, and then this x, and then n minus 1, then the power gets 1 subtracted, so it will be here 3 minus 1. This is the differentiation of the function x cube. And similarly, by the help of this different formula, this power rule, we can find out the derivative of this x raised power 4. Even we can find out the derivative of x power some rational number. So with the help of this formula, we are now able to find out a lot of results. Now beta, we are going to prove first this result, that differentiation of this xn is nxn minus 1. And the second very important result that is from this power rule is the derivative of this ax plus b raised by n. We have to prove the derivative of this very function is equal to n ax plus b raised by n minus 1 into a. The multiple of this x, the factor of this x, or the quotient of the x becomes in derivative the factor of this whole function. So now we will prove first this result, and we know that we have the very beautiful method for finding out the derivative of the functions, and that is ab initio method or delta method. So we will follow that very method, and we have also one more rule, that is by the definition, and that rule is to find that is the limit x tends to 0, f of x minus f of 0, f of x minus f of a divided x minus a, or f of x. We know how to find that very by the method of when we will substitute x as a h. So now here we will follow the rule of ab initio method. So the first step that we are following in ab initio method, that is we have to take the function, this function which we have to find out the derivative, we have to take that equal to y. So we will take this xn as equal to y. So let y equals to x n. Then this is our first equation. After that, we are by the method tells us that you have to give the increment to this x, and that will give the corresponding increment to y, and we denote that increment by del x and del y. So we will give the increment of this x as del x and this y. So when we will give the increment of this x, it will become here, it will give corresponding increment to y, and that we will denote that del y. You write here now this y plus del y equals to x plus del x, and then we have power equals to n. This is our second equation. And the third step that we are following in the method is to subtract this first one from this second. So we will subtract first from second. So we check here, it will be y plus del y minus y equals to x plus del x raised power n, and then minus x raised power n. So here now you check this y and this minus y, they will get cancelled. Here it is now del y divided by del y simply equals to x plus del x raised power n minus x raised power. Now what is our another step, that is to divide this equation by del x. So we will divide here by del x. So it will be del y divided by del x equals to x plus del x power n divided minus xn divided by del x. So we are now here. We have del y divided by del x equals to x plus del x power n minus xn del x. So here now you check, which implies del y divided by del x. It will be equal to, now we will factor out this x from this x plus del x. So it will come out as x raised power n because the power is n. So inside will be now. So if this xn is here, no, you just write down the another step. Then it will become 1 plus del x divided by x raised power n minus x raised power n, and we have here divided by del x. So it will be now del y divided by del x equals to, you check here, xn is on the factor of this variable and also here. So we can factor out this xn. So it will be xn then divided by this del x, and inside the bracket there is now 1 plus this del x divided by x raised power n and then minus 1. Now we have this as a plus b, yeah, 1, or we can say 1 plus a ka whole raised power n, and we know that by binomial theorem this 1 plus a raised power n, it is equal to, by binomial theorem, 1 plus then n a plus n into n minus 1 divided by 2 factorial a raised power 2 plus so on. So up to the a raised power n. We have this thing. So we will now use this formula 1 plus a raised power n, this here. So, and instead of Raman we will get our result. So you apply here. So it will be equal to x raised power n del x. Now you check here. It is a plus b, a 1 plus a raised power n, and that is equal to 1 plus n a, and what is a here, that is del x divided by x, and then we have plus n into n minus 1, that is n into n minus 1 divided by 2 factorial, and we have, after that we have this thing, a raised power a square, that is del x square divided by x square, and then plus so on, plus last we have del x n divided by x raised power n, and then we have minus 1. After here, this is by the binomial theorem. So we have used here binomial theorem. Now you check, this is 1 plus and this is minus 1, so these two will get cancel out. So we will get here x raised power n divided by del x. Now here it is n del x divided by x plus n into n minus 1 divided by 2 factorial del x square divided by x square plus so on plus del x n divided by x n. So after here it is understood. Now we write it here. We are getting this del y, this ratio of increments, we are getting it equals to x raised power n divided by del x into n del x divided by x plus n into n minus 1 divided by 2 factorial del x square divided by x square plus so on plus del x raised power n divided by x raised power n. And now this is equal to x raised power n divided by del x. You just check here, this del x divided by x, we can factor it out as common because it is in every term. You check here, here is del x divided by x, here is also del x divided by x, and it is, so we can make it as a common factor. So here it will be now n plus, this one will be n into n minus 1 divided by 2 factorial del x divided by x plus so on, and this one will be now last, we have factored out as del x divided by x. So now you check here these things, so it will be xn divided by del x, and then this as multiply del x divided by x, and then we have n plus n into n minus 1 divided by 2 factorial del x divided by x plus so on. So now del x and del x will get cancelled, and this is x raised by n divided by x n, so it will become x will get cancelled and it will become x n minus 1, and then n plus n into n minus 1 divided by 2 factorial del x divided by x plus so on. Now the final step that we are following, from the method of delta, that is to give the limit of this del x of this ratio as del x tends to 0. So we will take limit as del x to 0. Taking del x tends to 0, we get, then we will give that this del x as 0. When we will approach this as 0, we know that this ratio of this increments, it becomes derivative of the y with respect to x. So here it will be equal to dy by dx equals to, now you check here, it is limit del x tends to 0, and then x raised power n minus 1 n plus n into n minus 1 divided by 2 factorial del x divided by x plus so on. Now you can give the value of del x as 0 directly by the direct method. Why? Because when we will give the value of this del x as 0, this thing becomes finite. So when we are getting a finite value, we can directly give the value of del x. So we will give here del x as 0. So it will be x n minus 1, then n plus, here you check, del x is 0, so this term has del x as multiplied, so 0 into some finite value, that is 0, another term will again become 0, and till the last they all will become 0 plus 0 plus 0, so on. So now we are getting dy by dx, we are getting it equals to this x raised power n minus 1, x raised power n minus 1, and then n. So it will be now n into x raised by n minus 1. This is our solution, because this is dy, we know that y we have taken as x raised by n. So that means d by dx of this y, that is xn, by the first step we have taken y as xn equals to n of xn minus 1. Hence proved this was our result. So we got the derivative of this xn equal to n xn minus 1. So you take some examples. So find derivatives of the following. The first one is x raised power 5, second one is x raised power 3, third one is x raised power 2 divided by 3, and the fourth one is x raised power 2 divided by x raised power 5 divided by 2. So I will do the first one, I will solve the fourth one. I have to find the derivative of this d by dx of this x 5 divided by 2. So it will be, this is x raised power n. We know that by this formula it is n, that is 5 divided by 2, and then x raised power n minus 1, that is 5 divided by 2 minus 1. So it will be 5 divided by 2, x raised power 5 divided by 2, that is 5 1 5, 2 minus 2, that is 5 minus 2, that is 3 divided by 2. This is our answer. So it is easy enough for you to calculate these examples. Now we will solve the another one, and that is prove that derivative of this derivative of this ax plus b raised power n is equal to, you have to prove it equal to n ax plus b raised by n minus 1 into a. This is actually the general result, and from this result you can make this as corollary. This first one, x raised by n, you can derive this result from this result also. So we will solve this one. Prove. The first step that we have to do is to take this as y. So that y equals to ax plus b raised by n. But I don't think we will get enough time, so we will first do some simple example for this result, and after that we will prove it. If we have a function that is 5x plus 2 raised by 3, and we have to find out its derivative. So its derivative will be plus 2 raised by 3. Its derivative with the help of this formula is n, that is 3, ax plus b, that is this function, that is 5x plus 2, n minus 1, that is 3 minus 1, that is 2, and then a. What is a here? That is 5. So it will be now 3 5 15, 5x plus 2. So this helps us to solve the examples of this kind. So or if we have a linear equation and having power 2, then we can solve that, we can find out the derivative of that very function by this. So this was the example, simple example that is based on this, and with the help of this you can solve the exercise. So now here the second, you will take this one. Second step is to give the increment to both x and y. So we will denote the increment of y as y plus del y equals to, this one here it will be a x plus del x, then plus b power, and now we will subtract this first from this second. That is our second step. So it will become y and y will get cancelled. It will become del y equals to this a x plus del x plus b whole raised by n minus ax plus b power n. So this thing. So now it is equal to, check here, it will be, we will make this ax plus b, here it is ax plus a del x plus b raised by n minus ax plus b raised by n. So we will make this ax plus b, we will make it as factor out, so it will be here ax plus b raised by n, and then inside it will be now, here it is now from these two, we have make them common, so it will be 1 plus this thing, that is a del x divided by this one, ax plus b, ax plus b power n, and then we have minus 1. So this thing we got here. Now you go for here, it is now equals to, sorry beta, it is here 1 plus a, so it is now here, this one I was looking for n, so now minus 1. Now it is again the formula as a plus or 1 plus a ka raised per n. By the binomial theorem we can give its expression, and we know that what is the expression of it, so it will be now here a x plus b raised power n. You check this, it will be by the binomial theorem 1 plus n a. What is n? What is a? A is this thing, nx, that is this, so it will be n a del x divided by ax plus b. After that it is plus n into n minus 1, that is n into n minus 1 divided by 2 factorial, and then we have this thing a square del x square divided by ax plus b ka whole, and then we are after the end, and then last we have this thing minus 1. So now you check here, this is plus 1 at this moment, these two will get cancelled out, so we are getting here this del y equals to ax plus b raised power n, and then n a del x divided by ax plus b plus n into n minus 1 divided by 2 factorial, this del x square and a square also divided by ax plus b ka whole square, and then this is our result after here. So now just we have done in the previous result, you can make here this del x divided by this thing as common, because it is everywhere. So you make this common, it will become ax plus b raised power n, then this is now a, then del x divided by ax plus b, ax plus b, and inside will be it. So here it is now n plus, here it is a, n into n minus 1 divided by 2 factorial. Now n is everywhere also, so you can make this n as common also. So it will be now here n into that with n minus 1, that is del square, del x square divided by ax plus b ka whole square, and then plus 1. Now when this n, so it will be now here 1. So now the next step is to divide this del y by this expression by del x throughout, and then take the limit del x tends to 0. When I will do, it will be del y divided by del x equals to ax plus b, ax plus b divided raised by n is divided by x plus b, so it will become here above n minus 1. Then here it is a and n del x, when this will get divided by del x, so it will get cancelled by del x, so here it is nothing now, so into 1 plus a n minus 1 divided by 2 factorial, del x square divided by ax plus b ka, and del x plus ax plus b, because we have this del x as common. So it is now easy, because we can give the limit as, it is just same as to the first result. It is same, so it is, there is nothing complicated here to understand. So you can now you can approach the del x as 0. When we will approach del x as 0, this one become dy by dx, and then here it will be now ax plus b raised by n minus 1, and then a, and then n 1 plus, when we will approach the del x as 0, so del x is 0, 0 into pi net 0, 0, 0, so here it will be 0 plus 0, so on. Now dy by dx, we are getting it n ax plus b raised by n minus 1 into a into 1, that will again come as this. So now this dy by dx, that is y is d by dx, but y we know that it is, we have taken it as ax plus b, and we got it as n ax plus b n minus 1 into a. So this was our result. We got that the derivative of this function is n ax plus b n minus 1. So this is our result, and these are the most beautiful results of power rule. So you have to make them in your mind, understood in your minds, and after that you have to apply them to solve the result, to solve some function. Now it is enough for today. Hope you have understood it. Inshallah Rahman, tomorrow we will go for another method. This was power rule, and we will go for another, and we will find out the derivative of some trigonometric functions also. So this is enough today. Have a good time ahead.